Hi guys, welcome to a new video. Today a Signal K special, the heart of OpenPlotter. We use our MacArthur HAT and dAISy HAT and so on. Let's go. So last time we installed on our Raspberry Pi 4 OpenPlotter and we noticed that Signal K is the heart. If you have a MacArthur HAT like me, all this data which you can get physically must go somewhere, and Signal K is the best place to put it. And Signal K can distribute it to other sources. We also have a dAISy HAT on top, so get AIS data. So we have a lot of inputs. I also have a GPS mouse connected, one wire temperature sensor. Let's grab all this data, make a Signal K deep dive, and let's see what we can do with that.
So a little recap, we won't do the complete installation again, so you should have installed OpenPlotter already, and if you have installed OpenPlotter you have Signal K also installed. So when you go to OpenPlotter and into the settings, well, you saw it already also here, so Signal K is existing. Signal K can be accessed either locally on the Raspberry itself, localhost port 3000, or also from any other mobile device which is in the same network with the IP address of the Raspberry and port 3000. You can use the access point of the Raspberry itself, or you can wire it, or whatever you like to get on your Signal K server. We will do a lot with the server, so we come to that. You see also in the background already my PC browser accessing the Signal K server, because this is the quickest solution. We also have several other items here which are necessary on OpenPlotter to get data to our Signal K main system. I2C for the I2C sensors, GPIO for one-wire interfaces, or if you even want to connect a general pin. Of course, Mayana would be nice if you have one. And what is PyPilot for the tilt sensor, which is an I2C sensor. Serial is quite important, because on serial we also already last time installed several of our sensors, and we should start to check this one, because serial is important. So last time, and I don't want to repeat everything, we used already serial to enable the two outputs of our MacArthur HAT, input-output of NMEA 0183. So you simply enable UART3, UART5, and under devices we set names NMEA 1 and NMEA 2, and on connections we added them to Signal K, which is already installed here on our machine. And I also, this is my USB GPS mouse, did add one GPS source. I have also UART source here, but this is neither NMEA nor Signal K format. And then I have a my dAISy HAT, but I have to enable UART 0 for that. So that's what I'm going to do now. Yes. So we did a restart now, and we see that another interface did appear. If we go on details, we get some additional information. Yeah, so we have to Google this if we want to identify it. Not sure if we would find that this is my dAISy HAT, but in this case I know it. So let's call this dAISy, and we know it's sending, and oh, funny, it's up here. Oh, don't know why. Okay, it's NMEA 0183 data, so apply. And we have our device virtualized here as a dAISy, and now we just need to add it to Signal K. And you see that the server in the background is restarting, so the Signal K server is open here on my web browser, and it is restarting. And after restart, you can see that on the dashboard we got the dAISy here on top as an additional device. Okay, so this is the dashboard in Signal K, and it's really nice that you can see input and output activities here from our connections. This is our AIS, just a few messages which are coming from 1 or 2 ships nearby, not a lot. Then our GPS input, all the GPS information, except the 2 sentences we filtered out last time. So this is what is ignored. And then we have NMEA 1 and NMEA 2. These are our 2 connections on our MacArthur HAT. And what you can see here is that this is an output currently. Why? Because this one here is sending data out as we configured the output event for this port, and we said it's in NMEA 0183. What does it mean? This event is always existing in Signal K. Everything which is received, which is in the format in NMEA 0183, is written into this event. And if you put it on any output, if you have an output, and you put this in, the complete NMEA 0183 events are sent out. So because also the AIS data is an NMEA 0183 event, it's also sent out. If you don't want this, you need to suppress this event. And if we would do this, then it wouldn't be sent out here because this event doesn't contain the dAISy information. And we wired NMEA 1 and NMEA 2 so that we receive the data on NMEA 2. So that is our setup. And when we take a look at the data browser, we can see all this data which we receive, not which we send, by the way. You see the input here currently. And this is everything on GPS2 and NMEA 2, so we can't see NMEA 1. But you will also miss the dAISy information. But it's an input information, so why is this missing? And the reason is here on top you have to select the context. And the context is automatically or by default set to self. And self means this affects my own vessel. And the AIS information is something else. And you see that I currently receive 3 vessel information. So I just pick one of those and I get, if I pick this context, my dAISy information. And why do I see also the NMEA 2 information? Because currently we still have this event selected that it's created. So let's turn this off. We suppress this event so that our NMEA 1 output is not sending this information anymore. We have to restart. Okay. And after the restart, when we now take a look at the vessel information, we just see the dAISy. We will receive the other vessels also in a second. The vessels are not sending this information so often, maybe every 30 seconds or so, so it may take a while before you have them all together. Okay, before we dig deeper into Signal K, take a look at the API and the data fiddler and everything, we want to add some additional sensors. So especially I2C is interesting, but we start with a one-wire interface now. And if you want to use I2C and one wire, you need to enable this in the Raspberry Pi configuration, so our Raspberry Confi, which we can also access via OpenPlotter. So after we install GPIO, we get again access request, in this case again from OpenPlotter. I will access them with read-write or give them a permission for read-write access. Now the GPIO should work the application if it's installed and everything is connected and you have the access rights set. When you go to the one-wire interface, you will see the option set one-wire GPIO, and we have to do this because currently it's set to pin 7 or GPIO 4, and this one is using UART 3, so this will be an issue, and we need to set it to GPIO 19, which is somewhere. This is GPIO 10, but pin 19, so be careful with that. And here is GPIO 19. So, okay. And we have to restart again. Okay, we're back in the GPIO app. On the digital settings, you can add inputs and outputs for your GPIOs, but you need to be careful with that because a lot of GPIOs are used by the HAT, And in this case, we don't want that. We want to use the one-wire interface. Also, the one-wire interface is using GPIO, but pin 19 as we have set it. And this is the pin which is officially also free for one-wire by MacArthur HAT. And that's why also one sensor is already found. You can connect more than one sensor to this same input because it's a bus system, but we have just one sensor connected. Let's edit the sensor because it's now just connected and found, but it's not available in Signal K, and we want to make it available there. So we can edit a key. Key just means what kind of data is in there and for what type it's the information. So for example, it could be something for your electrical stuff or your environment, so your depths and maybe some inside temperature if you have this here, or for your communication, and of course for steering, for your autopilot and so on. So we could now take the inside maybe temperature or pressure, whatsoever. We can also take this from our engine. It depends where the sensor is attached to. And you always have a joker, a star you have to replace, an asterisk. So we will replace this now and say this is the real inside temperature whatsoever. It's just for testing. Okay. I have to say replace and okay. I'm not sure. So you can define an offset. I'm not sure if you need to define the rate. I think it will take 1 second rate automatically. We don't want to have an offset here because our temperature sensor is hopefully working. And now it's set in Signal K. So when we go back to Signal K, we will find some additional information here. Maybe this is it already. Let's take a look. So you see that here are several read-write clients on my system. Let's go to the data browser. We are still in the vessels. This should be a self-context again. And maybe when we search for one wire, we found it already. So this is the OpenPlotter one-wire information. And you see this is exactly the path which we defined. So environment, temperature, and our replaced part. And we get a value in Kelvin in this case. Signal K is always using Kelvin. Yeah, so you need to deal with that on the Signal K level. If you later want to show this in a different unit, then your dashboard or whatever you're using must convert it or has the ability to convert it. Okay, what can we do with all this data except of forwarding it and so on? You can use it on web apps. And one of the integrated web apps from the beginning is the instrument panel. And now let's exactly do this. We want to see the temperature in Celsius. So we go to the instrument panel, and I currently have just two widgets set here. So we go to modify. This is this tool sign here. And you already see here it is the temperature in Kelvin. So we say show on grid, edit, and change this to Celsius. You can also switch between a rather analog widget style or digital. So we take the digital now, and you go to view, and you see the temperature is there in Celsius. You can now modify also the position and place it wherever you like with the temperature. And of course you can add all the other information you have now on Signal K available to build your own dashboard. So it is quite interesting to get all the data into Signal K. And as we learned, we can use several inputs like I2C sensors if they are supported, like one-wire sensors if they are found and supported. Like, of course, NMEA 0183 and the Seatalk input. So especially with MacArthur, we get them all together. There might be still some additional things which you can't get in directly with the OpenPlotter onboard tools. So there we have to look if we use the API of Signal K to forward this data directly. Okay, by the way, you can take the direct link to the instrument panel dashboard. So there is a special what is it here? I think Signal K instrument panel. You can see this on the lower left. And if you put this on your bookmark, you can directly go there. You don't need to take this route, so that you can put it on your tablet or whatever you like. Okay, so this is the principle of Signal K. By the way, there are a lot of more apps available here, more than 100 if you go through all the available apps. But we can't go into every detail. When you go to your dashboard and you take one of your inputs, and inputs is something, I didn't mention this, but when you go to data connections here under server, you can also define your own input. We did this now with OpenPlotter, so OpenPlotter created this for us. For example, GPS2 or GPS and NMEA inputs were done by Serial. We did also one input for one wire using the GPIO port. So this is something which we can do using the configuration here also on data connections manually. Okay, on this section you define also your input and output. So if you have created them or they have been created by OpenPlotter, you can also change something. For example, the ignored sentences, so sentences you don't want to get into Signal K at all, or you define something as an output also, if it has output capability and you want to set events or send events out as well. You can also create additional input events. You can repair checksums and so on. So it's a lot you can do. However, yeah, we won't do this all today. I would love to go into details about the API, but I decided now we do this in an extra session talking about the API, because that's also quite interesting to get data from other sources or your own sources in directly to Signal K. Okay, one really important thing which I would like to add today, because that's a core of Signal K, is the server. So not the Signal K server itself, I am talking about the server for the NMEA 0183 over TCP. So on the port 10.11.0 there is this NMEA 0183 server. Also, a Signal K server is existing if the client understands Signal K data. So on this server, automatically on this port, data is sent which is marked as NMEA 0183 if it's not suppressed. I give you the first simple example. So I think we suppressed the dAISy, right? Yeah, so I will remove this now, apply, and let's suppress the GPS so that we don't have too much data there. So I suppress the GPS now and I restart. We test the connection, the TCP server. One important hint: you should read the NMEA 0183 multiplexing chapter on the OpenPlotter documentation, but because it explains very well how this event handling is done. So every NMEA 0183 data is automatically sent to the Signal K server and automatically sent to the TCP server. If you have additional data, for example, Signal K data, then you need a plugin which is automatically installed. Also, if you have, for example, NMEA 2000 data from the AIS system, then there are two plugins. You will find them here in the server configurations, plugin configuration, and there you can configure your N2K AIS to NMEA 0183 and the Signal K to NMEA 0183. For what we are currently doing, it's not necessary, because this is pure NMEA 0183 data. This is automatically, this event is always there if it's not suppressed, and automatically sent to the TCP server. So this TCP server should exist now. It should at least contain the dAISy data, the GPS data we did suppress. So we will now use a simple command shell, and I will use Telnet, which I installed on my Windows machine. I will go to my Raspberry's port, which is, or not port, but first IP. I can't speak and type at the same time. And now the port, and this is our 10110. And let's say OK. And now it's connecting to the TCP server, and when we get data, we should see it. So as I said, AIS is not sending that often, so it might take a while. On GPS, we would get much more. But you see here now I got a NMEA sentence which was forwarded based on AIS data. If you turn on now on the dashboard the GPS as well, so I remove the suppress, apply, restart. So you see that we lost the connection, of course, because the server is gone. Do the same again. And you see it's much more information. It's the GPS information and sometimes also AIS. I hide my exact position, even if you know where I'm almost located. Okay, and of course the main purpose for that is to get this in Plotter. So I just took now OpenCPN on a Windows machine. You go to configure. You can do this in almost any application. This case it's connections. It's a network-based connection. It's TCP in this case. The address, it depends now if it's installed on your Raspberry. You can use localhost. In my case, or if you are connected via Wi-Fi, it's the address, it's what is it, 10.10.10.1, but in my case it is this address, the data port, the 10.11.0, and apply. And you see that it's now enabled. I turned off GPS again, but I kept the AIS on. So I hope we get some AIS data here, and you see already there. I got a vessel which I can see here and get some information and so on. And of course, when I have GPS on, I also get my own position. And yeah, also here you can build your own dashboard. But that would be another session, because I think we're already over 20 minutes.
So I think Signal K is the perfect software addition to our MacArthur hardware, and of course also the dAISy HAT or other AIS sources, GPS mouse, one-wire sensors and so on. So it gets the data in and it can distribute the data, can multiplex the data to various clients. So it's a perfect addition. It has even an own dashboard integrated to visualize the data. So cool tool. There is another way to get data in and out in Signal K, and this is API calls or WebSocket connections. But it's a topic on its own, I would say. So I will do the second part for Signal K Special, and this is API connections. Hope you're looking forward to this. This will be the next video. So hope you enjoyed also this one, and stay tuned. See you next time.
See you next time.